Claire. Hello. Thank you so much for joining us today.
Thank you.
Pleasure to have you. So you're a professor in forensics and environmental science at Staffordshire University, and you've been there for 18 years, which seems like quite a long time. What kept you there?
That's a really good question. 18 years is a long time, actually, isn't it, to be in one particular organisation? I tell you what it is. It's the dynamic nature of the job that, if I was doing the same thing for 18 years, I don't think I'd be doing the same thing for 18 years, to be honest. But because it's changed so it feels really rapidly. I mean, it doesn't feel like 18 years. And I feel like the role has changed. The work that I've done has changed, partly because the world's changed. We've got different challenges now than we had, 18 years ago, both in forensic science and sort of criminal justice sector, but now also when we're thinking about environmental sector as well. And I think because of that, the job feels day to day different. But then looking back over the years, so many new avenues have opened up because of these different challenges. It's just kept me completely sort of immersed. And being at Staffordshire University, we've been doing forensic science for years, my goodness, decades. So I'm very well seated there in a very well established department that allows me to be able to sort of start, tackling other challenges. So I'm very lucky, actually. I really am. I really feel it.
Yeah. And I mean, I just half wonder if it is in fact the nature of it that has changed, that has kept you there, or is it your inquisition that has really led the change? Which do you think it's more of?
A little from column A, a little from column B, I think, because the things that are changing, I mean, some of these things, I mean, they're really serious, things that we really need to sort out at a societal level. But at the same time, I've always been pretty nosy about sort of what is going on and what are the current challenges, and asking questions, for example, of the police. So what do you currently find more difficult now? What would you like to do? What's your vision of the future of policing and using forensic evidence? And I think I've asked those questions constantly, and I'm getting answers, which then opens more doors and leads to these projects that, honestly, some of them, if I look back over time, completely different to each other. They really are. And I think that sort of being inquisitive and trying to find out people's problems and, stakeholders' problems, that's the thing that's ended up sort of making such a diverse job.
Yeah. And I think we kind of skipped over it just when my glib introduction at the beginning. Forensic and environmental, they're not a natural fit together necessarily, are they? Forensics and environmental science. And you were the first forensic scientist to actually use the same technique and approaches into environmental research. What made you think of that? What made you think, hang on a minute, this could work there?
This is So this is where I started looking at microplastics particularly. But just to add here as a little aside, environmental forensics. It is a thing. It is a thing. But most people, or when I say most people, when we think of other forensic science, if you say, what do you think about environmental forensics? They'll go oil spills, things like that. Mm. And it'll be like illegal waste management, dumping of rubbish and things like that. There's also wildlife crime investigation, which, is a whole area in itself, is something I do too. But the bit that kind of ended up with me having this forensic and environmental science professorial position was all about microplastics. And that's really where I was sort of the first to go, hang on a minute. I've been looking at fibres for many years, but from a forensic point of view, how can we tell two people have been in contact from looking at the fibres that could have come from their clothes? And what methods do we use? How can we interpret that? And how can it be useful for a case investigation? So I'd spend all my time on that. But then, over the last, around 2015, I really started to really get into this environmental element of this, was where I was saying, well, hang on, the environmental sector is sort of wanting some similar questions to be answered. So they want to know, for example, how much microplastics are there in a particular, say, body of water or in the air? How's best to analyse them? And what does it all mean? And I kind of sort of two and two together. So we go, well, that's the questions I've been asking for, my entirety of my career. But from a crime point of view, can I do the same thing, but from an environmental perspective, and really try to improve the science that's going there? Because, it's not, you're not sending people to prison. are we? And, the risks for getting the science wrong with forensic science, of course, is huge. We don't want to convict an innocent person. We also don't want a guilty person to get off free. And when we think about microplastics in the ocean, I mean, these are serious concerns, but it's not necessarily we're pointing fingers and people are going to jail. But we are making big decisions. And, we're doing bans, we're bringing in new legislation. And if the data that supports that isn't robust enough, in my opinion, that's a problem. So maybe it's a little overkill, but my big thing is being, well, the science that we're generating now, the methods we're using should be just as good as the stuff that we use in forensic analysis. It's good enough for court. Fantastic. It should be good enough for our environment, because we are serious about that as well. And so that's really been where I've kind of overlaid these two areas, the methods we use, the way we interpret it, and this idea of just great science for the purposes of looking at the environment as well.
Yeah, I mean, I completely agree. You're quite right. And it is harder when you're looking at something to do with the environment. Yes, you're not sending someone to jail. I mean, arguably, should we be? Who knows? Maybe that's a question for another day. But then, so just tracking back just a little bit to pre-Staffordshire University, were you always interested in great science, as you delightfully call it?
I've definitely always been driven by science. But I have been someone who's changed what I wanted to do as a youngster many times. Going back, I wanted to be a sailor. I wanted to be a jockey. I wanted to then be a vet. Then, and all of these things, how you sort of like you change, you go on with this. But the one thing that I really realised that I really loved throughout all of this was science. And that's sort of what I pursued with qualifications and that before university. But it was the investigative part that got me. And I absolutely set myself as what do I want to do? I actually want to be in the police force. And I want to be someone who's investigating these crimes, but from the policing perspective. And back then, it's different now, but there are certain criteria that you need to enter the police force, and your eyes are one of them. Now, I've got terrible eyesight. I really have. I'm really, really short-sighted, and I didn't even reach the threshold, nowhere near. And I was told quite, quietly when you have these assessments, and this is not going to be possible. And I was absolutely devastated. Absolutely. I thought, well, I kind of set myself for this now. I'm 18 years old. This is what I want to do. And now I can't do it because of something as silly as I'm short-sighted. So it was my mom who came in and saved the day, in fact, because she said, well, you're interested in this idea of investigations, and you've always loved science. Yeah. What about you combine the two? Have you thought about forensic science? And do you know what? I hadn't. Well, it wasn't that I didn't know anything about it. What I knew about it really was from TV, crime dramas, etc. And I thought, hang on a minute, this sounds quite good. And I looked into it a little bit more about this idea of applying science for the courts, and the fact that it uses, well, it's not even just science, engineering, computer science. When we think about geology, you can pretty much put forensic in front of any subject discipline if it's for the purposes of the courts and, criminal investigations, for example. And that intrigued me. And I thought, science for this purpose is ticking all the boxes of what I'd like to do. And I don't have to decide right this second before going to university what I'd like that forensic discipline to be. Because I learned early on, you do need to choose one. You can't be, like it is in the TV, an expert in absolutely everything. Forensic scientists can answer all questions on all. You've got to be an expert in a particular area. But I had the opportunity to actually sort of start thinking about that and exploring, my goodness, how would I like to apply what science to what evidence type? And that I knew, actually, as soon as I started going into my degree, I knew this is it. And I'm so glad. Isn't it funny how these things work out? So glad I ended up down that route. I work a lot with police forces. I find it fantastic, but I love this forensic side of it. So it definitely all worked out in the end.
Certainly. And I bet your tutors adored you and your enthusiasm and your complete focus on what exactly you wanted to do.
Yeah.
A favourite tutor?
Oh gosh, I had a whole heap of them. You know what got me was the passion, the absolute passion for this sort of crime solving and this kind of sense of responsibility that the tutors gave you. And they said, you're doing this job. Think how important this will be. And at the same side, same time as this sort of responsibility and that it didn't dampen it. It made it exciting, to be honest. But it was also this idea that you could look in so many different avenues in forensic science, and if anything, it gave me a little bit of choice paralysis because I thought I loved everything. I mean, drug analysis, absolutely fascinating. This, application of chemistry for the analysis of drugs. But next minute, I absolutely love footwear impressions. I'm like, oh my goodness, how do you start linking, literal shoes to scenes, and I thought, I love that as well. And then I love trace evidence, which is, ultimately what I've ended up in. And it was this passion for all of these different disciplines, just, fantastic. So I think I'd probably ask too many questions, if I'm honest. So I don't know whether
no such thing as too many questions. So you're kind of, it's kind of unusual because you catch all the criminals in a way and save the planet at the same time. So it's sort of you're a public servant in a way without actually being one.
Yeah, I suppose I am actually. Yeah, I've got a responsibility for both crime fighting, making our streets safer. Ultimately, that's what we're trying to do, isn't it? At the same time, think about sustainability and what does our future look like? We can solve crime, but we also need to solve some of these environmental issues because ultimately we want a safe, sustainable, clean planet, don't we? That's what we want.
Yes, if we can get to that,
we can get to that, that's the goal.
Yeah. So just moving then on to some of the techniques. I mean, you use microscopy and IR spectroscopy. Do you want to talk a little bit about the application of those and how, the different things have worked and how much of it's actually done in a lab versus out in the wild?
Yeah, there's so many different techniques that can be applied. And when I think about trace evidence, in fact, a lot of the time I'm focusing on fibers. We also focus on hairs as well, but also other particulates at the same time. So, of course, plastic fibers and plastic polymers, this is also what I'm looking at in the environment, but it's also glass, paint, rubber, and all these lovely particulates that transfer from places. And what that means is that not just one technique is enough. So you can start off nice and I say relatively simple and get the optical properties, your morphological properties. That's great. Microscopy is fantastic for that. It really is. And it's really all about building a forensic strategy from that initial information, because you don't want to be throwing another 3 or 4 different techniques on these samples if right at the early stages they can be screened out as maybe limited importance, low priority, given the fact that you might have many particulates. You've got to understand which ones are going to be the most useful in this case, bearing in mind the case context and the different maybe garments, if it's fibers, suspects garments, etc., that are in play. So it's very much, I always call it the layer cake. So you build it up like a cake, a many layered cake, I may add, of different techniques and information about the evidence as you go along. And you end up with this, not an even cake, because you are every sort of step of the way, you're trying to understand, can I, and this is a word we use a lot, differentiate between these samples? So say the ones from the suspect compared to ones from the crime scene. And you're throwing more techniques at it. So the next step, for example, could be Fourier transform infrared spectroscopy, which then adds this more information around its chemical properties. Might use Raman spectroscopy for the same purpose or similar purposes. Might use microspectrophotometry for trying to quantify the actual colour or the dyes, for example, that are in the fibres. And every single layer of information that you get allows you to come to a more robust conclusion. Because we'd never go to court saying, we found some red fibres at the scene and the suspect was wearing a red jumper and that means that person was there. Without this, what's red? What type of red? What's the fibre made out of? What's the shape of the fibre? Because it can be made in all different shapes. We call them cross-sectional shapes. Has it got any additives in there that have been added in by the manufacturer? All this information starts giving you that, well, it's not just a red fibre. Could have been a red fibre from that jumper. And there's a whole other areas of then interpretation we use with that information. So, how common is that jumper? Is it mass produced and very little variation? And actually, can you not really tell the difference between that one and another one? Or in fact, is it a lot rarer? And that rarity of the evidence, based on all this information, the techniques you've used, really allows you to make that judgment. Is this low value evidence? It's going middling, or is it actually really high value? It's what we call probative value, really, really high. And there's cases where that has been fantastic. The Sarah Payne case is a great example, There was one fibre there, and it was literally just a few fibres that got found. But this one particular fibre was a cotton fibre. And we know how common cotton fibre is. But the way that it had been printed in terms of the dyeing actually on the original fabric gave it these properties, these qualities to it that actually made it incredibly rare. And it was able to be identified to actually a particular source of fabric that was in itself quite rare. And ultimately that helped lead to the conviction of Sarah Payne's murderer. And it's that understanding of all the different layers of information, how rare they are, that gives you that end outcome or that conclusion.
That's extraordinary. And I was exactly going to ask, what are the high profile cases? You've asked it. You've answered it. Have there been any more?
Oh yes. There's a lot of cases actually where fibres evidence particularly plays an important part. For example, there's something called the Ipswich murderers, which was based in Ipswich, and it was a series of women who got murdered, and there was fibres and hair evidence actually played a really key part with understanding, again, not just about linking people, but how did they get there and when did they get there? Because the beauty of the likes of fibres evidence is that it's not just the who. And, arguably, I'd be happy to talk, when we talk about fingerprints and DNA, and, the who is better answered with DNA and fingerprints when we think about uniqueness. But when we think about fibres, it also helps answer the when and the where and the how. So in the Ipswich murderer case, it was trying to understand when ultimately the perpetrator came in contact with these women by trying to understand something called transfer and persistence. So in simply put, the evidence transfers between two people. How long does it last on that person? And you can actually understand that through a series of experiments and things that we know about these particulates and how they act, that we can start thinking about timelines and starting to answer the question, well, it looks like they came in contact at this particular time frame, which then might marry up with other eyewitness accounts, time of death, for example, and it makes it incredibly powerful. So it's great the way that this evidence is not just used to be able to go, does this help identify the who? It's really more about the other questions. It's reconstruction of the crime scene. That's what it's helping to do.
You sound almost like an artist, actually, when you're talking about it, especially when you talk about the building, the pattern of the analysis and the strategy. It does sound more like an art form in some ways. It might be just the way that you're describing it, but it does sound wonderful. So, I mean, you've done so much. It's hard to choose the next thing to ask you about. I kind of want to skip ahead to some of the microplastic research, because you've traveled so much. You've certainly done, gone to all these extraordinary corners of the world, the Great Barrier Reef, the Hudson and Mississippi rivers, you've been to like farmland in Turkey and the sea in the Antarctic. I mean, God, what a range. I mean, where even to start from the traveling section? Shall we start with the Barrier Reef? I mean, you were the first one the first forensic scientist to apply a forensic science approach to microplastic research, which we've already got touched on, but you were also part of the team that first discovered microplastics being ingested by deep sea organisms. Tell me a bit more about that.
Yeah, that it's a roller coaster ride. I absolutely love it. And I always say, just to add here, if anybody ever wants to combine science, travel, and adventure, do environmental forensics, absolutely, because you've got unbelievable places and unbelievable samples, and that's the thing. And the thing with the deep sea organisms, it was such a great opening for me into the world of microplastics, because this research was being driven by the Natural History Museum in London, and they had gathered some of these samples, and they asked such a important question. I'm so glad they asked it. They asked the question of, well, we've been noticing that we might be able to there might be the presence of microplastics in these really remote locations. So, for example, they were taking biota, different organisms from really, really, deep environments, 1,400 meters, 1,700 meters. And they're also taking sediment samples, so they're taking sand samples and that as well. And at one point, they said, hang on, I think we might be seeing some microplastics here. But this is the important question. How do we know that those microplastics, microfibers in this case, they're all fibers, how do we know that they are actually from the deep sea being ingested by them? And it's not just contamination. that has happened somewhere during the sampling, somewhere in the laboratory, sometime during the analysis. And that is where I, for the first time, got asked this question of, okay, is there any forensic procedures or protocols that you would use in a lab, for example, out in the field, to prevent contamination that you think we could start applying to these samples for the purposes of trying to understand if there's any microplastics in the deep sea and being ingested? And I thought, oh, this is such a good question. Yes, I'm in. I'm absolutely going to help out with this, because that is our bread and butter. You cannot do forensic science without constantly thinking contamination prevention, because in court, if they ask the question of, could this sample have been contaminated? And you can't give an answer of how you have tried to mitigate or try to prevent that and monitor potential contamination, you're in a lot of trouble. So that application of, can we do that in these incredibly dynamic environments? And those samples that were from the deep sea were taken on board a huge research vessel. It was called it's James Cook. Massive. They have wet labs, and I've subsequently worked in lots of different wet labs and things like that. And it's not like your lovely controlled environment that you have in a laboratory, in a university, in a forensic provider's setting. No. It is, if you're going to get contamination, it's going to happen there. So the protocols that have got to be put in place have got to be so strict and well thought out. And that's ultimately what led me into looking at these samples, helping develop these protocols from the forensic science industry, and then doing the analysis using forensic science analysis methods so that we could start understanding how many different potential sources were they, what are we actually seeing down there. And part of that process was for the biologists there, the marine biologists, to start going, let's think about the locations. Now we know that it's these ones here are not procedural contamination. What does this mean in terms of these animals? And of course, this included dissections, etc. And it was clear that they were ingesting them, which, when we think about these very remote locations, and at the time, there wasn't that much done on things like remote deep sea locations. In fact, the main piece of work that was done there was actually one of the team that I worked with, and very little that was understood. When you start realizing that our fibers from most likely clothing and other objects are ending up in those deep sea locations. I mean, that was shocking to me. I'm not surprised when I expect them to be in crime scenes. I expect them everywhere. But the fact that they're in the deep sea at those depths was crazy. And it really started my thinking and my work around microplastics, because that's where I started thinking, well, contamination prevention, that's definitely one area that forensic science can help, but where else can forensic science help as well? And gosh, that's why we're sitting here talking about it today. So after all those years, these are the questions I'm still asking. How else can we help as forensic scientists?
Indeed. And it's interesting to hear about the dissections as well. I mean, did you just get a little sardine, or were there some bigger?
Oh, so the marine biologists there, who are they are very competent at these dissections, of course, and this is what they do, but they are handling things like sea cucumbers. So you imagine they can be quite big, different, like lobster types, but lobsters that live on the deep sea. So there's all different techniques that they use to ultimately try to dissect and sample those in from where they're actually feeding mechanisms, all the way to obviously other body parts that are of interest. So they are very competent at that. And then those samples under these protocols then get sent to me, which is fantastic. Kind of clean, but we don't expect clean samples. There's no clean samples when they've come from the environment.
And so how does microfiber pollution in ocean environments compare with other types of pollution, like, for example, I don't know, shipwrecks, or like the implosion of the Titan submarine? What is there a comparison? Is it too wildly dissimilar?
It's such an important thing to consider, because this idea of our macro litter from the many different uses of our environment, everything from like shipwrecks, etc., to just what we've got big garbage patches that are in the middle of the ocean. There is an accumulation of all of our waste that has escaped our waste treatment, and it from rivers. It all ultimately can end up in the ocean. There's huge amounts there. How does that compare? It's really interesting, because the problems with macro litter are different to micro. So macro litter, not only is it an eyesore, but of course we're talking about, ingestion by large mammals of this. And, we've probably all seen, especially in the media, where, they've dissected large mammals' bodies, seals, for example, being found with plastic around the necks where they've swallowed it, seabirds. suffering from starvation because their stomachs are full because it's full of these macroplastics. The micro is having micro effects to microorganisms, and our ecosystem's so diverse that we know at a micro level, when we've got that ingested by teeny tiny little organisms, this can accumulate up the food chain. So we're having different sources cause different problems for different organisms. So it's all a related question. It absolutely is. But we have to ask slightly different questions. We have to do different analysis techniques, and at a microscale, which of course what I've always done. I'm really interested in things that you don't necessarily see with the naked eye. That's always been of my interest. The analysis techniques you're going to apply there, because are going to be more diverse. They're going to maybe even be more complex, because you don't know by looking at a teeny tiny portion of this plastic, or what did it ultimately come from? Did a tiny little fragment come from a plastic bottle? Did it come from a polystyrene takeaway? Did it come from a plastic bag as a film? This fibre that's found, was it from carpets? Was it from washing people's clothes, and it's ultimately ended up in the environment? So it's more of an investigative question when it is of a small scale, because you go, how do we figure out what that has come from? What are our major polluters, versus getting lots of macro litter items that assume that we can identify that what the original source was, or a lot easier at least. So different challenges, but both problematic.
Indeed. And I suppose the answers to those more intricate questions, what's ultimately going to provide the solution?
Yes.
Because it sort of seems kind of satisfying in the criminal justice sense. If you find who murdered someone, they get punished. That's effectively the solution. But in the environmental research, there's a little bit more ground to cover before you get to that sort of real satisfying, we've solved it moment.
You're absolutely right, because we've just coming out of the phase of, are microplastics everywhere? And, we've pretty much every environment that there's been sampled, there's been in those samples somewhere some amount of microplastics being found. So the question of is it everywhere is really kind of been answered now. It doesn't mean that we shouldn't keep looking, because really what we need is very large data sets, robust data sets that really try to understand actually what's the scale of this problem in these different environments. And that could be environments such as one particular coastline, or it could be the difference between, air over a city versus the soil in the ground in that same city, like even thinking about different environmental compartments. And we need lots of data to understand the scale. So that research still has to, happen. But now it begs the question of, well, where's it all coming from? And what's the biggest source of these pollutants? And where should we put our energy? So, should we put all our energy in replacing plastic bottles? Okay, there's definitely some value there. I'm not being controversial here, but that's the same question we should ask. Actually, should we be looking at the fabrics that are being used in clothing? Should we be demanding somewhere, lobbying for these fabrics to be low shed, so that they are not releasing the same amount of fibres into our environment while we're wearing them and while they're being washed? Now, this is where it's an interesting point of view for me, because, of course, remember, I straddle the forensic and the environmental world. But imagine a world where we have got zero, it's almost impossible, but zero shed fabrics being worn. Yeah. So they're not polluting the environment, even when being washed. It's a bit of an extreme example, because that's incredibly difficult. But imagine that. Now, all of a sudden, we can't use forensic fibres for case investigations because they're not being shed and transferred between people and between scenes. So, my goodness, a solution for the environment from a clothing point of view is actually a problem in the forensic world. How interesting. So, does that mean that we just ignore the problem? No, not at all. Because we can think about more sustainable fabrics, and we can think about fabrics that are not, that are bio, when we think about bio fabrics that are more healthy for the environment. So the solution is not the end of one or the other, but it is something that needs to be thought about, and at a global scale, of course.
Of course. And there's always a knock-on effect. It's always easy, isn't it? And it's, you've got a wonderful perspective of such intricate detail into two different perspectives, which I think most people probably don't have. But that appreciation of how drastic change in one area is going to have such a significant impact in another. So, I've just skimmed through some of these publications, some of these papers you've written, and one of them jumped out at me in particular, and it was quite early on the list. It says the application of tape lifting for microplastic pollution monitoring. So this tape lifting, I just wondered if you could just talk me through that a little bit.
Yes, because it's unusual. It's an unusual title, isn't it? Like, what is this? Absolutely. So tape lifting is very much a forensic idea. We use tape. And when I say tape, think of like, it's akin to your sellotape that you would use for wrapping up your presents. It's that idea, but they have been, well thought out. They're much bigger, but essentially it's sticky tape that gets used onto surfaces of all different types. So we would take a tape, for example, and we would place it on suspects' clothes, on victims' clothes, on surfaces, door handles, anything where we think contact might have occurred. And the sticky surface, of course, picks up particulates. And we're hoping what that does, and we know this now because we've been using this for decades and decades and decades, and that recovery is getting the information that's on the surface. So, the more recently transferred particulates, the ones that we're interested in, the ones that are going to help tell us the story about what happened. So that's what we've been doing in forensic science for years. Years, honestly. Tape lifting, forensic science, it's a key piece of kit in any crime scene officers, scene to crime officers kit. But my thought was, well, can we use tape in a way to be able to recover microplastics from the samples that we're taking? Because a lot of the samples that get taken, they have to go through some sort of filter system. So if we've got water, we filter the water, and we filter onto filter papers, as you can imagine. If it's air and we're pumping it using an air pump, they're onto filters. So, these microplastics, invariably, even if they come from the soil and they've had to go through different separation things, they end up on a filter paper that someone has to then go through tediously, I may add, and go, is that a microplastic? Is that a microplastic? And try by eye actually pick these out. Now, of course, human error. A lot of these they're not clean samples, not clean filter papers. It's so easy to miss what are microscopic microplastics. But to get the better science, to get the better data, we want to capture everything on there. So my thinking was, well, we use tape for crime scenes, for microscopic particulates. Can we now use a tape on these filter papers for the same purpose? We recover them, and at the same time, we've got it in a very safe environment. Comes back to anti-contamination again. We've got them sealed on there, and then we can start searching, and actually not just searching just using high magnification. In fact, we could start searching using techniques that are going to help these proper pop out. So something called polarized light microscopy. There's a setting that you use there that if you have got anything that's called birefringent, I won't go into that, but essentially your plastics, the vast majority of them are birefringent. You pop this setting on called cross polars, and it's beautiful. It's like a light show. They all ping out, ding, 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 ding. Now other things are birefringent as well, but I tell you what, it's incredibly helpful when you're searching something, you think, oh, there's nothing on this. And then you put this setting and you go, oh my goodness, there's hundreds. And that allows you to visualize them, identify them. And in fact, that whole process allows you to get quite a lot of information as well. So you're able to get, what's the shape of them? What's the color of them? Have you got additives in? And even looking at that value, that birefringence value helps tell you what polymer type it actually is. Mm-hmm. So you get so much information really quickly. I'm like, I don't understand why everyone's not doing this already, because this is the kind of thing that we would do in forensic science. But at the same time as this, we did have a problem in forensic science, and this is how we end up sort of, one helping another like this, because a lot of the searching for evidence is manual as well. So you've got it on a tape, and that's lovely, but no one was using polarized light microscopy to do it, because all tape that was currently being used was also birefringent. Why? It's made out of plastics. So you're trying to look for a plastic fiber between a plastic backing and some plastic tape. Oh, surprise, surprise, you can't see it. So it always done manually. So it was actually having a similar problem to the environmental area, albeit at least they were contained in these tapes. So this is where me and a co-inventor at Staffordshire University developed this new tape for the forensic world to help them able to search more quickly using polarized light microscopy and other techniques as well, actually, for their evidence, which then got applied in the environmental world. So it's kind of that tape was kind of a helping hand for the forensic world, but at the same time, my goodness, we might as well do the same thing for environment as well. And now it's being used in loads of studies, which is fantastic to see. It really is.
It really, and is that one of the things that's one of the patents that you hold, that tape?
Yes, exactly, that tape, that design of that tape and that use of it. And it's nice to see these two worlds using this now. So this forensic science world, which we've got projects at the moment that we're developing a whole automated system, actually, not just about then being able to analyse it in the tape. It's about using automated systems to detect this evidence. And we're doing that for trying to tackle violence against women and crime type scenarios. But the same idea and the same approaches of being able to try to do some automated imaging, or image detection. So looking for this, we're doing for microplastics, because there's a huge overlap here. We're interested in the same materials, essentially.
It's just such an extraordinary level of attention to detail. It takes, I think, anyone's idea of attention to detail to a whole nother level, shines a new light on attention to detail, I think. And then that you've also won an award for collaborative teaching, and I'm thrilled actually to see that this is on here, because I think the most marvelous thing surely can be for children, students to listen to you and hear what a wonderful world they could be entering into. So what was that award for?
Oh gosh, yeah. So we're all about, not just me, I've got to say here, the team at Staffs, my colleagues, we're all about this. How do we engage others? How do we get people excited about science? And how, for our students, do we give them real life work scenarios, working with all these people we work with? How do we share that? And that's what that award was actually. Part of this was about how we set up, and from my point of view, how do I get students involved in things like Fibre's work with police and with police forces around the UK, so that two things. Firstly, the police have got some challenges and they really would like someone to be able to investigate this and think about new methods or new solutions and new approaches, like how can we use this evidence differently? And at the same time, how does that student get, before even getting a job in this world, get that insight into, oh my goodness, this is what it's like to work on investigations. This is the kind of skills and qualities I need. Getting to talk with not just us who work in this area, but all of our collaborators in all these different locations and places, that they then got this real, passion and then inspired to then move to that next level. So this absolutely is all from inspiring young children as well, and getting them to start asking questions and being critical, what should science be doing? How can we address these problems? And getting them excited. So that's exactly what that award was all about.
Well, that's one, but it sounds very, very, very well deserved, that award. And now you're a curriculum influencer. Are there any other areas that you'll be influencing? Policy, I think you've already had quite a hand in already. If you could change, we haven't got much time left, so we should probably, I shouldn't ask too big a question, but have you got a policy?
Well, policy's a big question, isn't it?
On your radar?
I tell you what, at the moment, right, I've really got my teeth into, and I absolutely think there's so many things that we can do to improve this, is that other area of environmental forensics that I mentioned, which is wildlife crime investigation. And at the moment, I'm working on a big project, actually, that spreads across Europe, lots of different partners. And what we're trying to do, and talking about policy here, is really improve the way that wildlife crime investigations are being actually tackled. Because there's a whole thing about all the, effort, resources, and everything that's applied to, so it's called human crimes against humans. When we talk about crimes against animals, and remember, this is animals part of our environment as well, what can we do then? How can we improve that? And part of this work is around forensic training and trying to understand how things can change in different locations across Europe to help facilitate those on the ground who are actually the ones who are detecting these crimes. But for example, they're not from law enforcement, they're rangers, for example. Mm-hmm. How do we empower those? How do we train those in forensic techniques? And how do we ultimately end up empowering those appropriately through correct legislation change, so that more of these crime scenes can be properly investigated using the same, the will is there, absolutely, but it's about improved resources. It's about improving, the structure of how these crime scenes get, and these crimes generally get investigated. And so that's one thing that I'm really into at the moment. And policy change, touch wood, part of this project has got something called a policy lab. And it is about how do we take this research, this working with these different partners from Bulgaria, Romania, Spain, Ukraine, and how do we help them implement what this project's all about? And that definitely, touch wood, that we're going to see some real impact there. That's what we're really hoping.
Fingers crossed. Sounds like they could do with something like that in the New Forest and other places like that. I mean, I don't know how you differentiate between an accident and a crime when it comes to hurting wildlife. But it seems like if you run into a horse in the New Forest, that seems fairly criminal.
Oh yes, you're absolutely right. You know what? And it's we've got a lot of ways to go as well in the UK. We can definitely improve the processes that we're using. We definitely can, and that's kind of part of this idea of this knowledge share and working. Because you're right, these are challenging crimes to solve, not only just because of this accident or other explained, a defence that gets given. A very common one is, I thought it was the shooting season for that particular animal. I thought I was legally killing that animal, when in fact it isn't. And there's so many complex factors to incorporate into an investigation. And at the same time, these crime scenes, remember, are outside in the middle of nowhere, really remote, in dynamic environments where you have to think still about evidence loss. So to be someone who goes to those crime scenes, my goodness, you've got to be tough. You have got to be able to see eye for detail. My goodness, it's really difficult to spot evidence in these environments, but it is still there. And that's what it is all about, improving that and empowering those as well that do this.
Well, I hope you make good progress in that area quite quickly. That would be very nice. Now, it's kind of hard to draw it to a close because I could probably talk like this forever. There's so much to ask you, so much more that's just going to have to go unsaid. But you're going to be speaking at Lab Innovations in November. So anyone who wants to hear more of you can come and hear you there in the Royal Society of Chemistry Theatre.
Perfect, yes.
We'll look forward to that. And I guess I wondered, it's slightly putting you on the spot, and I don't really want to do that, but just in case you have got something, do you have a book that you could recommend? What's your favourite go-to book that you've looked at? Is there
Yes. For those, so I'm just going to ask the question, for those that want to learn more about forensic science, a great book about this. And yes, it is a textbook that's kind of technical but not too technical, and it gives an absolute coverage for every aspect, almost every aspect. And it's called, as you probably guessed this, nice and simple, does what it says on the tin. It's called Forensic Science by Jackson and Jackson. And it is a great example of especially the huge amount of different disciplines in there. It gives you this taster for all of these, from blood pattern analysis, DNA analysis, to trace evidence, to all of this. So I always say, if you want to learn a little bit more, a little bit about each of these topics without too much depth, that's a great one. Love it. I've got it here on my bookshelf just underneath me.
Great recommendation. Well, thank you so much, Professor Claire Gwinnett. It's been an absolute pleasure.
Thank you so much. I've really enjoyed this.